In this video, we're going to learn about limiting and excess reagents, as well as how to calculate them. Okay, so if we go back to our cookie examples, we think of a recipe, 1 cup of flour, 1 cup of sugar, a cup of brown sugar, all the ingredients are the reactants. We'll make, like 2 dozen cookies. So the limiting reagent is going to be the reactant you run out of first, right? So whatever you have the least amount of is going to run out first. So if you only had 1 cup of brown sugar, but you had a pound of flour and a pound of regular sugar and a pound of butter, you had all this excess stuff, then the cup of brown sugar is going to limit how many cookies you can make. The excess reagents would be anything then that you had leftovers of. Okay, the limiting reagent will determine how much product you can make. So if you only have 1 cup of flour, you will only be able to make 24 cookies, even if you have leftover of everything else, right? If you have 4 eggs, you'd only be able to make 48 cookies, assuming you had excess of everything else. Okay, now limiting reagent problems are easy to spot because when you start to read them, they give you 2 amounts of things rather than just 1 amount. Okay, so if we have the example of 2 moles of magnesium reacting with 1 mole of oxygen to form 2 moles of magnesium oxide, a type of limiting reagent problem would be this. It says if you have 10 moles of magnesium and 3 moles of oxygen, which limits the amounts of products you can make, right? So you're given 2 amounts. You're given the amount of 1 reactant, and you're given the amount of another reactant. And then you can determine which one limits how much you can make. Okay? So the chemical that makes the least amount of product, we say, is the limiting reagent. So in order to solve these problems, what you'll do is you'll set up 2 stoichiometry problems, 1 for each reagent or reactant you're given, and you can select any product you want, unless you're asked specifically the amount of some type of product. But if you're just trying to determine the limiter, you can just pick any product and use that. Okay, and you'd see which one makes the least amount. Whichever one makes the least amount of the product, that is the limiting reagent. Okay, so let's do an example. So if you have 10.6 grams of copper and it reacts with 3.83 grams of sulfur, how many grams of the product copper 1 sulfide will be formed? Okay, so we're specifically asked the number of grams of the product. So we need to determine how much could copper make if all of this reacted, how much could sulfur make if all of this reacted. Whichever one makes the least amount, that's how many grams will be made, and will tell us which one was the limiter and which one is the excess. Okay, so we set up 2 stoichiometry problems using these values. So you've got 10.6 grams of copper, and 1 mole of copper is 63.55 grams of copper. And according to the chemical equation, every 1 mole of copper sulfate, there are 2 moles of copper used up. And then there are 159.16 grams of copper sulfide in 1 mole of copper sulfide. So we've set up our stoichiometry problem, and we calculate it all out. And so if we were to react all of this copper, we would make 13.3 grams of copper sulfide. So now we're going to do it for sulfur. Right? Set up the same problem, but we're going to convert from grams of sulfur to moles of sulfur. And then from moles of sulfur to moles of copper sulfide, and then moles of copper sulfide to grams of copper sulfide. And in this case, we get 19 grams of copper sulfide. So the answer to our question, how many grams of the product will be formed, the answer would be 13.3 grams. Because we're going to run out of copper before we run out of sulfur. Copper is the limiting reagent. Oops. So copper is the limiting reagent, and it determines how much product is made. Okay. So sometimes you're asked how much product is made, and you're given 2 amounts. So just like the problem we just did. So by doing the stoichiometry to find which one is the limiting, we get the answer to that question, just like we did in the previous problem. The smallest amount is the amount produced. Okay. Now I'm going to do this example, okay? And this example has another type of question in it. I'm actually going to do this on the Elmo for you, okay? So in this problem, we're told if you react 10.3 grams of aluminum and 51.7 grams of copper sulfate, the first question is how much copper is produced. So this is just like the problem that we just did, right? We're given the amounts of two reactants, and we need to figure out which one makes the least amount, and that would be the answer to our question. So we're going to set up a stoichiometry problem, right? So we'll start with aluminum, so 10.3 grams of aluminum. Every 1 mole of aluminum is about 27 grams of aluminum. Then we're going to use our mole to mole ratio, so grams cancels. So for every 2 moles of aluminum I react, I am going to make 3 moles of copper. Okay, and 1 mole of copper, and I've got to look on my periodic table to see how many grams. Copper is, I don't have a periodic table in here, let me grab it. Copper is 63.55. So 63.55 grams of copper. Okay, now let me set up the other one and then we'll just plug the numbers in. So here we've got 51.7 grams of copper sulfate. And for every 1 mole of copper sulfate, I have how many grams? So we've got 4 times 16 for the oxygens, plus, we just looked up copper, 63.55, plus sulfur is 32. So about 160, we'll just round it off. So 160 grams of copper sulfate. Okay, now the next step would be going from copper sulfate to moles of copper sulfate to moles of copper. So we see up here we have 3:3 ratio. So 3 moles of copper sulfate for every 3 moles of copper. And then the last step is 1 mole of copper is 63.55 grams of copper. Okay? And we'll go ahead and now plug in our numbers and see which one makes the least amount of copper. So 10.3 divided by 27 times 3 divided by 2 times 63.55. 36.36 grams of copper could be made if we react all that aluminum. And then we'll look at this one, 51.7 divided by 160 times 3 divided by 3, and then times 63.55. So here we can only make 20.53 grams of copper. So the answer to our question is how much copper is produced? 20.53 grams of copper is produced. Okay? And if we were asked the limiting reagent, we would say that this copper sulfate is the limiting reagent. Okay? Making the aluminum my excess reagent. Okay, so I will have leftover aluminum. Okay, now the next question says how much excess reagent is left over. Okay, so we want to know of this 10.3 grams of aluminum, how much is left over. So really what we need to know is how many grams of aluminum were needed to make this much copper. Okay, so there's a couple different ways we can set it up. We could set up a stoichiometry problem where we go from grams of copper sulfate to grams of aluminum. Okay, or now that we have this product, we could see, okay, how many grams of copper, if we have 20.53 grams of copper, how much aluminum was made. And I'm just going to do that, but either way is fine. Okay, so we'll start and say, so if I can make 20.53 grams of copper, and I know 1 mole of copper is 63.55 grams of copper, and for every, we've got to look up at our formula here, for every 3 moles of copper, I need 2 moles of aluminum. And 1 mole of aluminum is 27 grams of aluminum. And all of this will cancel. Okay, and we get 20.53 divided by 63.55 times 2 divided by 3 times 27. 5.81. So the amount of copper or the amount of aluminum that was needed was only 5.81 grams, right? This is how much was used. Okay, we started with 10.3 grams. So if we want to know how much is left over, we would just take 10.3 grams and subtract the 5.81 grams, and that means we would have 4.49 grams of aluminum left over. Okay, so I've given you all sorts of different examples here, and we'll get to practice these in class, and we'll actually be doing a lab with limiting reagents.